Hello and welcome to Pondering the Picture's Purpose, determining the instructional purpose for creating a tactile graphic and developing a plan. I am Leanne Grillot. I am the Senior Director of Outreach Services at the American Printing House for the Blind. Tactile graphics is one of those areas that's near and dear to my heart, and I brought along someone else who I think has the same feeling.
Good afternoon, everyone, or morning as the case might be. My name is Jenny Wheeler, and I am APH's Regional Outreach Specialist for the Southwest. And this includes Arizona, California, Colorado, Nevada, New Mexico, and Utah. And today it is my great pleasure to talk with all of you, wherever you are, about one of my favorite topics, which is tactile graphics, and specifically the process of determining the instructional purpose of a graphic. By the time that we're done here today, I think we'll all be able to create a plan for creating a meaningful and relevant tactile graphic. Also, we'll talk together about valuable resources to support designing tactile graphics and methods for continuously improving and refining our tactile graphics. So first, by way of introduction, a little bit of a review. We all know that a tactile graphic is an image that provides information through touch. And it has qualities that allow someone who has a visual impairment to understand the purpose and elements of a print illustration. But tactile graphics are very special because they are representations of visual and conceptual information. They're not photocopies or precise renderings of visual images. They're very unique and individual. There are a lot of people who make tactile graphics, and they make them very well, starting with our transcribers, who create them for textbooks and recreational materials, and high-stakes tests, and also assessment tools. And our teachers of students with visual impairments, who make individualized classroom materials and teaching aids. And our orientation and mobility specialists, who create tactile graphics as representations of maps and orientation concepts. And our parents, who make them for experience and storybooks and story boxes and many other purposes. And also our braille readers, who create tactile materials for their personal and academic use, including assignments that they submit in their classes. There are many skills that are inspired and empowered by the use of tactile graphics, and this is only a small list, starting with conceptual development. Also, understanding of content and the relationships between objects and within objects, and social and test-taking and handwriting skills, and learning of orientation and mobility concepts, and motor skills and spatial awareness, and so much more. The most important reason for creating a tactile graphic is to provide equal access for our students with visual impairments as to that which their print reading peers enjoy, and also because they deserve to have beautiful tactile graphics that are fun and meaningful for them. However, it's not always necessary to represent print graphic information in a tactile graphic format. And there are some very specific academic reasons for representing information in a graphic form. For example, a pictured object might be unavailable for our students to fully explore or handle, like a snowflake, or a chemical reaction, or the planet Jupiter, or a meteor. The object that's represented in an image might be too dangerous to touch, and maybe our students can experience it in other sensory ways, but they should not touch it, like an erupting volcano, for example, or poison ivy, or a campfire. Also, an illustrated object might be too small to be touched and understood fully, like a plant cell, or a gnat, or an atom. Maybe the scale of an object is too large, so the opposite, like a skyscraper or the solar system, or the Earth's inner layers. Sometimes a diagrammed or illustrated phenomenon might be difficult to explain, either verbally or in writing, like a rainbow, or a collision of tectonic plates, or the parts of a human heart. Sometimes we need a map for a route between 2 points, or maybe a student needs to understand the shape of an intersection or a store layout. Sometimes a print graphic can't be described without giving away the answers to comprehension or analysis questions, and in cases like that, a tactile diagram might be needed. It is good to remember always, though, that a tactile graphic should provide new information that is not a repetition of text material and doesn't exist already in some other form or in perhaps a more effective form for a student. And that brings us to initial planning and classroom collaboration. I hope that this part of the presentation will save you a lot of time and make it possible for you to create the most relevant and most useful graphics for your students. When you first begin examining a graphic, there are a couple of questions that you want to answer, even before you get started creating it. First, whether the tactile graphic is absolutely necessary, and if it is, how to represent it in the best possible way. And that is why we're here today. As you're going through this initial planning process, there are some sub-questions that you can ask yourself to make this easier. First of all, what concepts are in the image that you want to convey to the student, and what exactly do you want your student to learn or be able to do with those concepts and the way that the graphic is represented? Does your student need the information in a graphic form to answer questions or participate in class discussions? What graphic elements are information and what elements are decoration? We'll talk more about that in just a moment. What information in the print graphic is necessary for a student's understanding and what information is unnecessary? And is there complex information in the graphic that can be simplified? So now a little bit about information versus decoration. And this is really a great place to start in deciding what you want to include in a tactile graphic and what to exclude. And it's pretty self-explanatory. If the material is necessary for a student to complete an activity or to gain better understanding of a concept or an idea, it is essential information. And so you'll want to include it. And we'll also talk about inessential information. If the material is meant to be entertaining or pretty, or specifically for visual information, or for visual interest, then it is decoration, and you can exclude it. Now, depending on purpose, there are some decorations that can be given a verbal or a written explanation, and a really good example of that is comics. Even though you might not create a tactile graphic out of a comic, there's still going to be information in there that the student might want to have for various reasons. So sometimes there are things that can be effectively described that our students will enjoy or find meaningful, even if they're not represented in a tactile format. And these can be given verbal or written descriptions. Context is really important when you're deciding whether something is information or decoration, because the exact same illustration could have a different purpose in a different context, meaning that sometimes it could be decoration and sometimes information. I have it as an example, a science diagram, a science worksheet. What can electricity flow through is the title, and it has 3 illustrations, and all of them very simple and some similarities between them. The first illustration shows a light bulb that's connected by wires to the 2 ends of a battery, a simple electrical circuit. The next illustration shows the same light bulb and the same battery, but this time they're connected to a small piece of aluminum. And in the third illustration, the same light bulb and the same battery are connected to a question mark. So you can see each one of them similar, but there are some important differences. And each one of them also has a small passage that refers to it, but does not explain or describe it. And so each one of these illustrations is new information, and a tactile graphic of each one would not be difficult to create. Now, if I took the first illustration, which is the light bulb and the battery, and I put it at the top right of the first page of a test on electricity for my students, but nothing in the text refers to the same graphic, and the student doesn't need it in order to complete the test successfully. It's just there for visual interest and as a reminder of what the class has been studying. In this case, it would be decoration rather than information, and it might actually distract from what my student needs to complete, and also will take time away from the information that's in the test that the student needs to refer to. So context really matters. There's so many supports for our teachers of students with visual impairments in their classrooms, and many of these are housed with the classroom teacher, like the teacher's edition of a textbook. Often these teacher's editions will come with student texts, and our classroom teachers will have them. These have additional explanations that help to identify images' purposes and whether a graphic is necessary and what material can be excluded from a transcription or needs to be included. Also, teachers will have supplementary course material like worksheets and manipulatives and commercially available graphics, and also activities that develop understanding. And your classroom teacher is actually one of the most important sources of expertise and collaboration, a very important human resource. So let's look at that relationship a little bit more closely. All of us know that developing positive and supportive relationships with our classroom teachers is essential for our work and for our students' success. But it's also true that in the case of tactile graphics, our teachers really need to understand the process of tactile graphics creation and how much time it can take to create one of these, and all of the reasons for ensuring that our students have timely and equal access to them. So a conversation about this at the beginning of the school year and then repeated as necessary throughout the year is going to be very, very helpful. But also, an organized communication system will help a lot. So you can use a form like the sample that I'm going to show you on the next slide. My sample here is titled Braille Transcription Request Form. And this is just an example, but you can take it and use it in whatever way is best for you. The instructions on the request form say, please complete the form below and attach it to a clear copy of the print image, diagram, or illustration to be transcribed into Braille or tactile graphic format. If there is an electronic format available, please email it to me as the TVI and place the following information into the body of the email. Thank you for your cooperation and assistance in submitting items at least 2 weeks in advance. So very friendly and very straightforward and very hopeful as well. And then the teacher can fill in the information below, the subject and the teacher's name, the date and the period needed, the purpose of the graphic, and also any special instructions or explanation that go with it. So let's look at this a little more closely to see its value in saving you time and helping you to produce the best and most relevant graphic for your student. My first example shows a science diagram. Its title is Mitosis versus Meiosis, side by side. It shows the process of mitosis on the left side and the process of meiosis on the right side. Both of these are very simple diagrams. So they have a few circular areas that are connected by arrows, and they're very similar to each other as well. Mitosis has a few labels that show the steps in the process. So replication, cell division, and daughter cells. And then meiosis has very similar steps, replication and cell division, and then cell division again. So here I pause to ask myself our two original questions. Should I transcribe this as a tactile graphic? And if I do, how will I do it? So before I even start, let's look at what the teacher has to say, because the teacher will probably give us some pretty good information. Mr. Ray from biology has filled out my request form, and he says that the instructional purpose is to introduce the process of what happens to chromosomes during mitosis. So that is very helpful information. And in fact, I might be able to use it to pare down my graphic a little bit, because my graphic shows both mitosis and meiosis. So I'll look a little further. I will be showing this on the PowerPoint, but wanted Joe to have a copy at his desk. This is not in the textbook. Now, this is extremely valuable information because I know now that this is new information. There's not another form of it for my student, Joe. So definitely, I'm going to answer yes to the first question. I will transcribe it as a tactile graphic. How I do that, I might actually go and have a conversation with the classroom teacher and say, after the students study mitosis, will they study meiosis? And perhaps I'd like to create each one of them, but the first one that I'll do is mitosis. So that simplifies this for me a little bit. The teacher has given me some incredibly invaluable information that will really help to save me time and provide my student with the most relevant tactile graphic. Now let's look at another example. It's quite different. In this example, we see the full outline of the state of Florida. We also see small parts of Georgia and Alabama to the north, the Gulf of Mexico to the west, the Straits of Florida to the south, and the Atlantic Ocean on the east. And this is a very, very visual and busy print graphic. It is full of cities and rivers and lakes and beaches and bays and coastal plains and parks. For me, as a busy TVI with a lot to do and a heavy caseload, this might feel very overwhelming because I don't know what part of it is going to be most necessary for my student. And I will have to provide it to my student and then also help him to understand what's on it. So before I answer my two questions, will I transcribe this as a tactile graphic, and how will I do it? I'm going to look at what the teacher has to say. Fortunately, Mr. Steele from Social Studies did fill out my request form, and he says that the instructional purpose is to learn the shape of Florida, as well as the locations of Tallahassee, Tampa, Jacksonville, and Miami. And all of a sudden, just with this one sentence, my work has become much more manageable and much more reasonable, and I understand exactly what to do with this. Mr. Steele continues with special instructions and explanation. Please create the attached map of Florida along with the major cities. The other information is not needed. Sorry for the last minute request. And it's a good thing that this information is not needed because I probably got this morning and Joe needs it this afternoon. But I can do it with materials that I have available to me. I can create the outline of the shape of Florida, and then I can create 4 points on it for Tallahassee, Tampa, Jacksonville, and Miami. And my student knows exactly what he needs to learn, and I know what he needs to learn as well. Let's look at one more example, which is similar to this one, but has different complications. This is a map of the entire world. It shows all of the 7 continents and most of the oceans. It also shows James Cook's Pacific voyages, 3 different voyages in 2 different ships represented in 3 different colors, green and red and purple. And these crisscross over the entire world and around the continents. And this is also a lot of information. So before I answer my questions, which are should I transcribe this and how will I do it, I'll look at what the teacher has to say. This is Mr. Steele again from Social Studies, and he says that the instructional purpose is to learn the different voyages of Cook's routes around the world. The map will be shown via a website to the class. In this case, part of the answer to my question, will I transcribe this, has to do with whether or not I have the resources at hand to make this effective. Are there things that I can use so that I don't have to recreate the entire map of the world and so that my student can have it in a timely and relevant way? And the answer to this is yes, there is. Actually, there are a lot of things available, and here's just one example of them. This is World at Your Fingers, which is from American Printing House for the Blind. And this particular representation of the world is a large tactile reference map. It shows the major oceans and land masses of the Earth. It has high contrast raised surfaces, braille and print labels, and textured lines and areas. And it does show the major mountain ranges, rivers, and lines of longitude and latitude. For this student's assignment, not everything on this map is necessary, but it does have the outlines of the continents, and it does have labels for the oceans. And I can use materials easily at hand to create the routes that my student needs to understand Cook's voyages, or he can create them himself. And this is just one example of many beautiful things that are available for you. So part of the thought process involved is also looking at the resources that you have at hand. And if you know that there might be something that you don't have right now, looking into the possibility of getting it for future graphics. And that takes us to the actual process of making decisions.
So here we go. You've had lots of examples. We'll have more as we continue on. But let's look at some of those steps. You heard Jenny talk about, what questions do I ask myself? So we know that most likely you're going to end up creating about 10 to 20% of the graphics a student needs, even if a textbook has been transcribed. So let's examine the decision tree in the Guidelines and Standards for Tactile Graphics of 2022 from the Braille Authority of North America, BANA. Now, we know that no diagram should be routinely omitted if a viable method can be found to render it tactually comprehensible. But on the other hand, the diagram does not need to add additional information if the text around it is already providing it. Sometimes the information in a caption is sufficient without including a graphic. A decision must be made about which would be more clearly understood by the reader. It could be a well-stated transcriber's note. It could be a tactile graphic. It could be a simplified tactile graphic with the transcriber's note, or even a three-dimensional model. Some complex diagrams will never provide meaningful tactile information. So we can go through the steps to determine ourselves what images need to be created as tactile graphics, similar to what Braille transcribers go through. Most of our materials are spur of the moment. Even if spur of the moment is 2 weeks in advance, wouldn't we love that every time? It could be that it might be used by another student, but many of our tactile graphics are a one and done. We can use our decision tree. We can talk and think about the author's intent, or in this case, the teacher's intent, as well as the learning objective of either the text or the teacher. We can actually ask the teacher. You saw examples of when we might want to reach out before talking to a teacher. And we should really ask our student and involve our student in some of the decisions. Their thoughts about tactile graphics can be very important. So again, this decision tree that I'm going to walk step by step through is available in the guidelines and standards for tactile graphics. In addition, there is an additional handout by Lucia Hasty about another decision tree. Again, great way to have a handout if you don't want to print out the one from BANA. Again, not all things need to be made into a tactile graphic. So we begin with, is the information a repeat of facts from the text? When a teacher hands you a packet, you might be able to find inside that packet that the diagram itself is a repeat of a written flowchart or outline, or even already a well-described graphic in words as opposed to the picture. And at that point, you can eliminate that tactile graphic. But if after reading it and examining the tactile graphic, you believe the information is more meaningful in text form, then you switch again. Let's see. Let me go back. Sorry. Okay. Is it a repeat of factual information? If it is a repeat of factual information and you believe that it'd be more meaningful in text form, you do not produce the tactile graphic. If it is not repeating it, then you're going to need a tactile graphic. Does the graphic require the reader to use visual discrimination or visual perception? Meaning the picture itself is a rendering of what we would see visually, such as a Escher's artwork, which is showing a repeating staircase. This would not be something that would make into a tactile graphic. The decision tree continued. Is the actual image unavailable, too small, too large, or too dangerous to examine by touch and perceive details? If it is not, and you are able to put the actual object in a student's hand, then you don't need a tactile graphic. Providing them the actual object is a better way to go. If that's not possible, then a tactile graphic is what you need to do. Asking, does the reader need the information from a map, figure, or graph to participate in discussions, answer questions, or complete a task? This is a great thing to ask your teacher if they've handed you something. If they don't need it and they can still participate, then you don't need to make a tactile graphic. But if all of that is relying upon that map, figure, or graph tactilely to be able to participate, then we would need to find a way to get that information to our students' hands. It's easier to talk about the flowchart by actually having a graphic at hand. So on the screen, we have a plant cell with all of the sections of a plant identified. And it does give the directions to use your book or other resources to correctly label the plant cell structures. Now, this one is already labeled, but if we needed to work with our student to be able to label something, they need to have a graphic in which to hold on to that information to be able to label. Well, do we need to produce this as a graphic? Let's go through the flowchart and see. So Is this information a repeat of facts in the text? Well, there is very little text and we don't know what might be in that student's textbook to be able to find. So for the moment, we're going to say they don't have their book with them. Since we don't have the book, we can't answer yes, which says don't produce the graphic. We have to say no and we move to the next question. Okay, well, would the information be more meaningful in text form? Listing and describing pieces and parts of cells might be helpful, but I don't know if it would be more meaningful. So I can't say yes and not produce the graphic. I need to say no and move on to the next graphic, or move on to the next question. So one note, when is a text more meaningful form of representation? Well, this would be when a graphic is complex and has many details that cannot be shown in a tactile graphic. Then a well-written description may provide better information for the reader. A print graphic may be more useful to the reader when produced as a tactile graphic and a description. So keep that in mind as you look over the tactile graphics that your student might need, that a description might help them better understand, especially if you are not available to be able to do a pre-teaching of a new graphic with them. Next question on the flowchart. Does the graphic require the reader to use visual discrimination or visual perception? Understanding a plant cell does not mean that you have to discriminate between two visual aspects of items or a depth perception stating that something is further away or closer than another. So it's not something that prevents us from creating this graphic. So we're going to move on to the next question. The next question, is the actual object unavailable, too small, too large, or too dangerous to examine by touch and perceive details? Plant cells are pretty darn small. Therefore, we definitely have to say yes, and we have to produce this graphic. If we had said no, we would move on to the next question. And the next question asks, does the reader need the information from a map, figure, or graph to participate in discussions, answer questions, or complete tasks? We've already said yes. So this question would have already moved us forward, but it does give you the indication if you had said no, you would have to make a decision at this point. Now, making the tactile graphic, making the decision to make the tactile graphic is just the decision. I didn't say how I was going to make this tactile graphic. And yes, I could use tools to make the plant cell from paper and hobby store items, but I could also look in the tactile graphic image library and find the plant cell and be able to emboss it or print it and use my own tools. Or I could use a item like the Build-A-Cell from APH and produce a plant cell with material that is already built as a kit for me. So thinking about those tactile graphic production methods. Let's see. What production method will you use? So is there a specific production method or graphing format being requested? Well, as TVIs, we're rarely requested a particular type of method. This can be done for many transcribers, but not necessarily for us as a TVI. Then look around you. What resources and equipment are available to create the graphic for that production method? Do you even have the ability to have multiple choices of how to produce a graphic? Which production method would provide the best readable graphic? Again, if your production methods are limited, you might also be limited, and you are just looking at what is a best readable graphic, but also possibly most preferred by your student. And then, is this graphic for a one-time use or for a production of multiple copies? If you happen to be at a school for the blind or have a small classroom with multiple students using tactile graphics, this is something you might need to consider. But I do know that a majority of those out there are more than likely only making it for a one-time request. Let's talk about some of these different graphics that you can use. Collage graphics. Sometimes people call it collage graphics or hobby graphics, or I just make it with the stuff I have graphics. These are teacher created using a variety of tactile materials that you can probably find at a craft store or around the house, maybe at the office or even in the classroom itself. It's probably the most common kind of graphics you create. It is very efficient. It is an on-the-go method for tactile graphics production. Now, depending on what you have access to, collage designs may be used to make an image for thermoform creations, and that would be when you are making multiple copies of the same collage design. I've listed some collage graphic materials. They are string and wire, puffy paint, textured paper, foam shapes, beads, fabric, craft glue or a hot glue gun, braille paper or brailables, labels and sheets. But what else? Get your fingers warmed up. Drop into the chat something you have in your collage graphic kit. What is something that you use? Or maybe what is your favorite item in your collage graphic materials? Graphic art tape. I could see using that. Puff paint, Velcro, both the hard and soft sides of Velcro. Wiki sticks, definitely. Buttons, jeweled stickers from the dollar store. Hot glue, a tracing wheel, Sculpey. These items are things that you could probably have on hand. And again, you might even find in the classroom itself when you need to make a fast collage graphic. Some of you might also use something like the Wheatley. The Wheatley tactile graphics can be designed as a collage graphic. It's just not a permanent version of one. So keep dropping those in. Those are ways that you can think about how you can create a collage graphic kind of on the fly. Another type of graphics are tooled graphics. These are durable graphics that are created with specialized tools. They can be teacher made or, of course, Braille transcriber made. Images are drawn on the back of an aluminum sheet or page. They're pretty sturdy and create well-defined, clear tactile images. Labels are brailled directly onto the foil with a slate and stylus. And these can also be used for thermoform creation if you needed multiple copies of the same graphic. Now, the APH Tactile Graphics Kit is a kit that provides you tools as well as aluminum sheets with the rubber mat to be able to create tactile graphics. I'm curious, are any of you actively using aluminum sheeting to make tactile graphics for your student? Drop a Y for yes or an N for no in the chat. Are you actively using aluminum sheeting to create graphs? I see a lot of no's. So let's talk a little bit about this. So creating foil graphics, the steps to do this are actually transferring an image on the back of the foil. This could be drawing it by hand freeform or by actually tracing or transferring an image to the back. Then going through and embossing the point symbols, lines, fine-tuning those lines, and then embossing aerial patterns. Then adding those braille cells and labels, and then of course erasing and fixing your errors. If you've never used this kit or haven't used it in a long time, actually our next webinar will go into detail on how to use the Tactile Graphics Kit from APH, which utilizes this aluminum sheeting and is another viable way to create tactile graphics, not only for you to create them, but also for your student to create their own. The next way that you might be creating tactile graphics for your student is machine-generated tactile graphics. So embossing, microcapsule, and that vacuum form that I was talking about. Now, for thermoform graphics, TVIs and orientation mobility specialists do not typically produce these. The machine itself is extremely expensive for a district to purchase. However, collage and tooled graphics can be used with the thermoform machine in creating them if you have one available to you. How many of you have students with textbooks that have some or all of the pages made with this plastic material with graphs and designs? I bet you do. Yeah, this is really common, and that's because it allows for the mass production of a tactile graphic. So they've created it using either the aluminum sheeting or the collage graphic, and they've moved it to this thermoform machine. As for micro capsule paper and fuse graphics, capsule paper is coated in millions of tiny thermal foam capsules, which respond to light and heat and cause that black images to swell. Some people also call this swell graphics. This swell graphics, swell touch paper, you're talking about tactile image enhancers or flexi papers, or you might have heard of picture in a flash or POF. The swell paper graphics, you create the tactile graphic in print and then you transfer it to the swell paper or flexi paper, and then you run it through a heat machine, or some people call it a toaster. Some of the things you need to think about is, are the lines tactile enough? Because it does depend on how much heat you've had and how thick the line is. And then you might also need to braille any needed information on the graphic, either digitally or after the fact, depending on what you're using. Again, a POF machine like this might be more expensive than what you might be able to afford in your program. Now, computer-generated graphics, when we get into specialized software and hardware, both on your computer, but also on braille note takers, this kind of allows you to produce tactile graphics through technology. Now, some of that technology could be the thermoform or that swell paper, but you could also have computerized and embossed graphics. So how many of you might have a PageBlaster, Pixblaster, or possible another embosser that is able to produce graphics? Now, not all are able to do this, but a large chunk of them are. You want to make sure graphics become a vital part of the Braille curriculum so that the pictures are no longer just omitted because you don't know how to create them. Both PageBlaster and Pixblaster do allow you this access by utilizing either Braille Blaster software, Firebird, or other items to be able to give you access to Braille graphics. And last but definitely not least, we can now create tactile, digital graphics using something like the Monarch. So you can download and upload a graphic on the Monarch and save it. You can use TGIL graphics on the Monarch. It gives you that full screen graphic display, but also the ability to pan in and out of the graphic, feeling the smaller details larger. There's a graphing calculator, which allows for meaningful images in real time of mathematical computations. And we need to remember that it is an important resource for graphics accessibility. There are multiple other creation systems, not only for us to use, but for our students to use. Put a Y in the chat if you know what a swale dot inverter is. Put a Y in the chat if you know what a swale dot inverter is. A swale dot inverter is a device that allows you to draw or create braille dots on the page upright without having to turn the paper over to feel it. It has a small pin with a small hook, punctures the paper, and pulls it up to create a raised dot, as opposed to pushing down and having to flip the paper over to feel it. Yes, a swale dot inverter does puncture the paper and create a hole, which does weaken the paper. This is not for a graphic for long term, but how many students draw and scribble, and really that drawing isn't kept forever? This is a great tool for your student to be able to create a tactile design and drawing themselves using a swale dot inverter and not having to flip it over to reverse the image. You might have your student or you using the Draftsman Tactile Drawing Board or the Tactile Doodle to be able to create their own tactile diagrams, and quick draw paper. Whether you use a marker or just water to raise the swelled sponge-like paper to make a design. Now, like I said before, collage method, and we listed lots of things in the collage method, time for you to be able to create these products by yourself. There are multiple tools that APH provides because it is recognized that TVIs are often needing to create graphics quickly. There is in your handout in the resources and tools document, all of these items are listed and to provide you access to them in a quick way. So go look at your resources. But these are things like the textured paper collection, the graphic art tape somebody mentioned, graph benders, all of the different feel and peel stickers like point symbols, the carousel of textures 1 and 2, the tactile book builder. We also have a tactile compass to be able to make circles, the tactile graphic line slate to be able to make lines straight in a variety of ways, and sensible strips. Now, some additional graphics to think about. One of the ones that I had mentioned earlier was using Build-A-Cell. This is a tool that's already in existence that already has materials to make a tactile graphic quickly. But there are other resources at APH to also put in your arsenal when you need a quick graphic for your student. It is very helpful for our students to use the same graphic about the same topic so that when you remove things, they actually can still identify them. In other words, that plant cell, we want them to learn the labels and what different pieces represent each part of a cell. But then when we remove the labels and then they have to label it themselves, we don't want to give them a whole new graphic. We want to give them the same graphic so it has the same representation so they're understanding what these pieces and parts of a cell are. Some of those helpful tools in your APH arsenal is the Earth Science Tactile Graphics, the Life Science Tactile Graphics, the Basic Science Tactile Graphics, of course, Build-A-Cell, the Basic Tactile Anatomy Atlas, the Setting the Stage for Tactile Understanding, the World at Your Fingertips. What are others that you might use, whether it's produced by APH or not? What are other helpful banks of tactile graphics that you use? Okay, I'm going to hand it over to Jenny. We've talked about different tools that are out there. Let's develop a plan.
Now, it's my pleasure to discuss with you the actual steps in developing your plan. First, some resources that we hope will be helpful for you in planning your tactile graphics. The first of these is the Tactile Graphic Planning Sheet. This comes to us from Lucia Hasty and Ike Presley in their Techniques for Creating and Instructing with Tactile Graphics. There are 3 versions of this planning sheet. One has supportive information on its use, and there's also a PDF version, and there's a fillable form version. Next, the Guidelines and Standards for Tactile Graphics, which were created by the Braille Authority of North America, or BANA. The most recent revision is 2022, so just recently, and this is a wonderful and comprehensive resource for best practices in tactile graphics creation. There's also the Tactile Graphics Manual from Holland and the Tactile Diagram Manual from Purdue. These are both available as PDF and EPUB and HTML formats. And while they're not BANA standards, they do provide many beautiful examples of both well-made and also poor graphics that will help you to develop your skills. A few definitions as we move forward. There are 4 basic elements in graphics, and they're illustrated here in this map. The map shows a small town, and there are 4 different kinds of elements illustrated in it: areas, points, labels, and lines. There's a post office and a cafe and a supermarket and a bank. There's a baseball field and a city park. There's a college and there's a train station. There's also some streets, Railroad Drive and Main Street and College Way, for example, and there's railroad tracks as well. So let's start with the first of our 4 elements in graphics. This would be areas. An area is a significant or sizable region in a graphic. So on this map, the baseball field or the city park might be an area. Other examples are states or provinces in a political map, stripes on a flag that have different colors, or layers of soil or rock in a classification diagram. And the second of these elements is the line. So a line is just linear information. It could be straight, it could be curved or wavy or zigzag. It could be an outline as well. So on this map, a line would probably be a street or the railroad tracks. Examples would be rivers, geographic boundaries, historical routes like we were looking at in Captain Cook's voyages, pathways in an electrical circuit, outlines of shapes, parts of an angle, or a length that a student needs to measure. The third of the elements is points, and a point is a specific place on a graphic. So on this map, that could be the post office, or it could be the supermarket. Other examples are location of a city, or a bus stop, or an oil well, or a point in a line graph for mathematics, or in a science diagram, something small like a gland. And the fourth of the elements is the label. The label has reference to all of the other elements. The label is the words or the alphabetic or numeric key used to identify an area or a line or a point symbol. So a label on this map that I have here might be a city park or the train station, either in full or as a keyed label. And we'll talk more about that soon. Let's discuss 4 basic steps of planning your tactile graphic. These also come to us from Lucia Hasty and Ike Presley in their Techniques for Creating and Instructing with Tactile Graphics. And in your handouts is the tactile graphic planning sheet, but I also have a representation of it here on this slide. There are 4 major sections in the planning sheet. There's areas and lines and point symbols and labels and keys, so the 4 elements of tactile graphics. And each of these sections has 2 columns where you can write some notes. On the left side, you can write the information in the print graphic that you definitely want to include in your tactile graphic. And then on the right, you can write the textures and the materials that you want to include that will make sense for that information. The first of the steps in the planning process is incubation. So it will be helpful to use a planning sheet like this to help you design your graphic. And you can take this sheet and use it in whatever way is best for you, or you can create your own sheet. The real need here is to write some notes on relevant parts that you can include in your graphic. And also to keep this and use it for comparison later, comparing it to others that you've already created and planned, or to ones that you might do in the future that are in the same series or subject area, or even different subject areas. Doing this really helps develop consistency over time. And as you know, consistency in style and production gives our students a head start in sorting out graphic understanding and also quickly knowing what's in a graphic. The second of the 4 steps of planning is educational purpose. And we've already talked a lot about this. This is where you spend the time reading the text surrounding the illustration, also looking at any activities or questions that are related to the graphic and figuring out the concept that's being taught, and making a note of what is the graphic's educational purpose and talking with the classroom teacher if that's helpful or necessary, and using resources like a teacher's edition of the text or other supplementary classroom materials. This step particularly is going to save you a ton of time, and as you get used to it, it's an investment now in saved time later and more consistency and more relevance. The third step in the planning process is determining what parts of your tactile graphic need to be most tactually significant, which have the greatest informational priorities. For example, in a map, are the buildings the most important? Are the streets the most important? Are they equally important? So in the first column on your planning sheet, you're writing down the information that you're going to include in your tactile graphic. And on the right side, you're writing down all of the textures and materials that you want to use. So list your informational items in order of importance or priority so that then you can use the most tactually significant materials to represent them. And then the fourth step has to do with looking to the future, which is tracking your work. So when your graphic is complete, then save a copy of it. It doesn't have to be the actual graphic itself. Maybe you don't have enough space for all of your graphics, or maybe you really like some, so you're going to save those, but not all of them. Or maybe the student's only going to use it that one time. But do take a picture of it, and then include your picture with this planning sheet, save it somewhere in a folder, and add notes about the materials that you used and how well they worked. And also get your students' feedback and add notes based on that feedback that will help you with future preparation and design. This is also something that really is an investment in the beginning and pays off a lot in the end. Then when you have a similar graphic later, your incubation is already done. Also keep track of the time it takes to produce each of your graphics, including the planning time. There are two major reasons for doing this. Number one, it's a good idea to share this information with classroom teachers so that they understand the time that's needed to prepare these graphics and so that they can get you these materials in advance so your students can have them when they need them. And the other reason is that it will help you to project how quickly you can complete the next assignment. You're going to have a pretty good idea for that as you move forward. Also, always helpful is a little bit of self-evaluation and self-reflection. I have here a self-evaluation rubric, and I would really encourage you to complete this with your student because not only will it give you some incredibly valuable information, but it'll be really fun. So some questions that you can ask post-graphic use. Was the graphic readable? Could it be understood with clarity? The student's really going to be the only one who can give you that information. Does it have enough physical definition for all of its parts to be legible and easy to read? Does it accurately convey the instructional purpose of the original assignment? Does it say what you intended it to say, and was the student able to use it in the classroom with relevance? And does it have sufficient detail without anything extraneous or distracting? Also, if appropriate, is it well labeled and titled? Is any of the text that's on the graphic easy to use and easy to connect with graphic elements? Does your graphic have good textures? No sharp edges, nothing really uncomfortable. Also, was it age and grade level appropriate? Did it really work for your student? Very individualized. And is it durable for its intended use and user? Maybe you're only going to use it once, or maybe the student needs to take it home, or maybe you want to use it again. Was anything falling off while the student was using it, or will it fall off in a backpack? That's good information to have as well, increasing durability as necessary. Now, just a few words about tactile graphics standards. These come to us from BANA's Guidelines and Standards for Tactile Graphics, which is a wonderful document with a lot of information, and I've taken from it just a few things here that I hope will be useful as you create your tactile graphics. We'll start with areas and we'll move through each of the elements in graphics. The standards tell us that areas should be at least 1/4 square inch. This is not very big because a typical cookie or a flash drive is about 1/4 inch thick. So for our students, our purposes, probably at least 3/4 inch or 1 inch square or diameter is better. It's easier to discern different textures and connect with labels if areas are a little bit bigger. You just don't want to make them too big to be easy to explore. So just for your reference, a dime is about 3/4 inch in diameter, and 1/4 or 25 cents is about 1 inch. That's about as small as you want to get. Then for primary lines, which are those most tactually significant lines, for example, streets on a map, the standards tell us that these should be at least 1/2 inch long. And this also is not very big. 1/2 inch is about half the length of a small paper clip. So for our purposes, at least 1 inch or longer is better. So at least the whole paper clip length. Lead lines are less tactually significant than primary lines. A lead line is a line that connects a graphic element with a label. These need to be about 3/4 inch to 1.5 inches long. So that's a pretty good standard, even for our purposes. And one end of the lead line should touch the graphic element, and the other one should be located at least 1/8 of an inch from the label. So don't put the label so close to the lead line that they interact, but not too far that it's hard to tell that they go together. Just for your reference, 1/8 of an inch is about the thickness of 2/4 and a dime stacked on top of each other. So you're going to want to use different textures or line weights for your lead lines and your primary lines. Less significant for the lead lines, more significant for the primary lines. And speaking of lines, let's talk about graphs just for a second, because the axis lines and also the graph lines are the most prominent lines that need to be projected on the graph. These should be more significant than things like grid lines. So use different textures and materials or line weights for the axis lines, the graph lines, and the grid lines, so students can easily discern what they are and use them. And then let's talk for a moment about labels. We want to place our labels at least 1/8 of an inch, that's the minimum, to 1/4 inch maximum from any graphic element. So not too close, not too far away. And if you're going to put one of your labels inside an area texture or inside a cluttered graphic element, like say the grid lines on a graph, then leave a little bit of space around the entire perimeter of the label so that it doesn't interact with the things around it. And then speaking about location, where should the graphic go on the page? Well, a pretty good rule is to put the graphic at the left margin of the page so that it's easy to consistently find and explore. So this means just basically line up the left side of the graphic with the left margin of the page. And then if there's text information on the page, leave a blank line before and after the graphic. So if you have a title, then leave a blank line before the graphic and after the title. Same thing with something like a descriptive paragraph or a caption. A few more best practices for tactile graphic design. We've talked about this a little bit. Make your graphics as small as makes sense while still leaving enough space for exploration and recognition. Once again, not too big, not too small, especially when small hands that are a little bit unfamiliar with tactile graphics are looking at them. Avoid clutter and keep your delineations between elements like lines and areas and points and labels as clean and discriminatory as possible. So don't put your labels too close or too far away from the elements they identify or anything else. Just a few words about keys before we move to our practice. A key is a list of symbols that appear in a tactile graphic. Symbols can be pictorial. They can look like dots or stars or triangles, or they can be textual, like braille labels. If a text label in the print graphic has only a single word or a really short phrase or mathematical expression that easily fits inside the graphic, then use the full label rather than keying it, because it is easier to look at a label in a graphic than it is to go back and forth between a key and a graphic. But, as often happens, if a text label is too long to fit in the graphic, then use an alphabetic or numeric or pictorial symbol system to represent them, and then include a key that lists their meanings. So I'll go through each one of these. For an alphabetic keyed label, you're going to choose 2 or 3 braille symbols that represent it. As an example, if I have something like Garden Street in a map and it's too big to fit inside my map, then I can use GR as my symbol to represent it. Or I could use GN. That would be okay too. I can use contractions in my keyed labels. So I could do G and AR contraction if I want to, unless I'm in Nemeth. If I'm transcribing my full graphic in Nemeth, then I can't use any contractions. So G and AR contraction will not work in that case. But most of the time you can do it, including short forms. Now, what I can't do is GA, because one of the symbols has to have a bottom dot, either .3 or .6. And the reason for this is that if there's not a .3 or a .6, then it starts to look a lot like the graphic information. So GA will not work, but GR would be fine. It's better to have 2 symbols rather than 3 if possible, because 2 is less to remember, a little bit easier to read. You can use a single braille character in a key if you want to. It's not preferred, but it's allowable. If you do that and you have an uncapitalized letter, then just include a grade 1 indicator so a student can clearly see that it's a letter. If it's a capitalized letter, you don't need the grade 1 indicator because the capital is sufficient to qualify it as a letter. Now, you can also use a numeric keyed label, and that just means using numbers to represent things. So always use a number sign. And also don't put a period after the number. It just gets too big and it's unnecessary. All of your numeric labels need to have numbers that are in the upper part of the cell. And this is also true even when you're transcribing a graphic in Nemeth. You'll probably have things in the Nemeth graphic that are numbers and they'll be transcribed in Nemeth, but all labels are transcribed as literary numbers. And the reason for that is because then they're clearly identified as labels rather than as numbers in the graphic. In your key that you'll include along with your graphic, list all of the symbols and their interpretations. And if you can, place your graphic on the same, or sorry, place your key on the same page as the graphic above it, if you have room. So let's look at a few examples of keys. First, a pictorial key. In this example, there's a tactile diagram that has a 10 by 10 square grid. And some of the squares in the grid have a symbol, like a short horizontal line or a short vertical line, or a hollow circle or a solid circle. There is a key above the diagram that identifies the meaning of 3 of the pictorial symbols used in the graphic. So we know that short horizontal lines mean red nose, and short vertical lines mean glasses, and solid circles mean red nose and glasses. And the meaning of the hollow circle is unidentified. It's a mystery to us right now, but ordinarily you would include all 4. This is a great example of a pictorial key. Here's a second example. The original print diagram shows a surveying crew measuring the distance to a tree across a river. And it's been simplified quite a lot so that there's a triangle and then there are 3 vertical arrows that point north. Also in this diagram, there are 3 numbers and they're ensconced in corners in the graphic. So there's 1, 2, and 3. And the key has been placed on the same page as the graphic because there was room for it. And I can look up at the key and I can see that 1 means 32 degrees, 2 means 37 degrees, and 3 means 53 degrees. So very easy for me to figure that out. The degree measurements didn't fit in the graphic, but it was easy to use a numeric key for them. And then let's look at a final example. We don't see here the tactile map that goes with this key because the tactile map is too big to fit on the same page as the key. The original map showed the continental United States. This is a really nice example of a place where textures and lines and alphabetic symbols were all included in a key. So there are 2 textures. One represents land and one represents water, and they're very easily placed on this page so that I can read them without trouble. Also, there are 2 different kinds of lines. There's a dashed line that represents a division line in the map, and there's also a dotted line that represents a state border. Then there are 2 alphabetic labels, one that says GL for the Great Lakes, and one that says GM for the Gulf of Mexico. And the person who created this graphic could have used GU as well for the Gulf of Mexico, or GL, and just chose GM. Any of those would have worked. But what wouldn't have worked is GF. And you remember the reason why? It's because there's not a bottom dot in either of G or F, and it will look too much like the graphic information. So something like GM will be better. And that takes us to our practice.
Okay. Get your fingers ready to join in a little bit of practice with us. Our very first practice is going back to the original mitosis versus meiosis worksheet that was described earlier that a teacher needed. The description of mitosis on the left and meiosis on the right. Jenny had described that. Let's see what you remember. So, was this a graphic that we were going to design as a tactile graphic? And would you have designed both mitosis and meiosis? What determination had you come to? I'm hoping that you at least said that you wanted to do the mitosis side because that was what the teacher wanted. So, in the chat, what method would you have used that you had in your arsenal of tools? Would you have used hobby graphics, like personal graphics to make it? Would you have used aluminum sheeting graphics to make it? Would you have used a Wheatley board? Would you have gone into the tactile graphic image library to see if mitosis is in there? Would you have found a way to make it a digital graphic turned into an embossed graphic using something like the Page Blaster or Pix Blaster? So we have some people that want hobby, some that think it is in the tactile science book at their school, a PIAF, the image library, Word, Microsoft Word. Okay. Okay, so we've got some thoughts. I'm going to describe what I would have done. Oh, I would check first to see if APH or the image library has it. If not, use the collage. I will tell you that I have fallen on using collage quite frequently for this one in creating a single sheet. If you are grabbing a single sheet of braille paper, probably the large to give me lots of room, I would sketch out probably in pencil the items and where they were going to align, the 4 different circles. The first circle, arrow down, second circle, arrow down and splitting into 2 on either side. And then I would have rolled my paper into my braille writer and added my braille labels, because once you stick stuff to that paper, you can't roll it in. I'm definitely better with my braille writer than my slate and stylus. After I had brailled them, I would then probably, depending on my time, probably my favorite go-to ended up being a hot glue gun, and being able to use a hot glue gun to not only attach textured, maybe circled shapes, but maybe using the hot glue gun to actually draw the lines. And maybe on top of those textures, adding in the chromosome lines inside of those circles, maybe with pipe cleaners, for example. I'm going to turn to Jenny. Jenny, how would you have made your mitosis?
Well, Leanne, I really liked the suggestion for Microsoft Word graphics. That's probably how I would have created it. But if I was in the classroom and I needed to do it quickly, I would actually probably love to do it with collage graphics.
We definitely have lots of other ideas that are in the chat for thoughts. Again, this is just trying to exercise your brain that there are ways to be able to create labels. I will say, though, if you've come up with an excellent graphic for something like this and you don't believe, or you think it might not be in the Tactile Graphic Image Library, you may submit an image to the Tactile Graphic Image Library if you've done something like this in Word that could be then shared with other people. So feel free to add and send things to the Tactile Graphic Image Library for their consideration to continue to grow that library for everybody's resource. Let's try another worksheet. Okay, this next worksheet is measuring angles. It says protractor practice. Use the protractors to determine the angle measurements. On the screen are 4 different pictorial representations of a protractor. Each protractor then has an angle placed already in a correct position to be measured. Each angle is then labeled with a letter, and then below it, it says angle, whatever the letter is, equals blank space. So what would you do regarding the protractor? So let's talk about the protractor. I do not want this worksheet to be harder for my students than any other student. All other students, the protractor is already perfectly lined up. The student already has the protractor set for them. They are really just learning how to track and trace that arrow to the line of the protractor and knowing which measurement to use, either the top or the bottom measurement. So this is already done for them. So I don't want to eliminate the protractor for my student, because they shouldn't have to line up the protractor like no one else did. So I cannot create that many protractors with that much information for each one. I am wondering if any of you have a solution of what you would do for this one. I'll give you a minute to think about it. I don't want to create these protractors, but I also do not want my student having to line up their protractor because no one else had to. Okay, I'm going to tell you what I'm going to do and see if anyone else had a better or a different idea. All of them work. I would have actually taken the pack of protractors from APH and actually mounted each one on probably its own sheet of paper after I had made the angle and allowed the student to use an already positioned protractor that I had either um, uh, glued down with a wiki stick would have held it on for a period of time, so that they could actually just practice measuring without having to position the protractors. And then I would have just taken the protractors back and destroyed the sheet to be used again. I'm curious what other people came up with. So one person said use the geometry kit from APH with wiki sticks. Graphic art tape for lines and hot glue. What would you have done for the protractors? The lines I was pretty good with, but the protractors were the piece that I wanted to make sure my student had equal access to. Tactile protractors is what I would have done. You can get a 5-pack from APH, and that's what I probably would have used, especially if I didn't have the ability to be with them, that this was something that they could do on their own. So remember, you don't have to make the actual tactile graphic. It's not meant to be a complete duplicate. I actually wanted my student to get practice with a true protractor and not have to do the lineup like anyone else. So, Jenny, do you have any other thing you would have done?
Leanne, hands down, I'd be using the tactile protractors. Absolutely, with the hot glue or the graphic tape, anything to make this as easy as possible and give my student the best access.
Okay, let's try another one. Line graph. Okay, so this worksheet has a line graph picture about Lewis's bike trip, and it's a distance in kilometers by time of day. And so from 9 till 3, each has its own point and continues to grow on how far Lewis rode. It has questions that are pre-answered on the top of the sheet, and then questions at the bottom that are blank that the student needs to answer. It is answering things like what time Lewis stopped for lunch for 1 hour, what time did he stop? He covered more distance between 12. Did he cover more distance between 12 and 1 or between 1 and 2? And then between which 2 hours did he travel 4 kilometers? So we know that he definitely needs the graph to be able to answer the question. So these are great questions to show, yep, I need to make this line graph for him to be able to answer these. So there are a few different ways I might make a line graph for my student, depending on how much time I had. Probably the first one that comes to mind is I would actually buy graph paper or get graph paper from APH. I possibly would pre-cut the size and glue it to a traditional sheet of braille paper and then label and use graphic art tape or wiki sticks for my line, and then use a some type of sticker for the dots. Might be one way that I would create this, just one of many. Jenny, what would you do?
I love the idea of using the tactile graph paper. Also, a large geometry rubber mat with grid lines would be really helpful. And then just some brailables for the numbers. And then you can use, for the rubber mat, you can use rubber bands, you can use push pins, but for the graphing paper, you also have a lot of options. So I like that idea very much.
And we had a couple in the chat, 2 tactile pens in different shapes, adding braille later to be certain it's in the correct position, make the dots with a hammer, raised line graph paper, or use puff paint for points, possibly pipe cleaners for lines, make the points with sticky foam board or with a hole punch, tactile graph paper, wiki sticks, foam dots, and labels made on the slate. So lots of different ideas and creative ways to be able to make line graphs quickly for your student. Here's another one. Let's see what you come up with. This is the water cycle. The sheet says this water cycle diagram needs some more color. Read the description of each part of the cycle and then draw a picture of the missing steps. It has condensation, precipitation, storage, evaporation, and then it has the definition of each of those four at the bottom. What would I do with this water cycle? I'll be honest with you. The first thing I would do with this water cycle is I'd go into the tactile graphic image library and see if there's a water cycle already created there. Pretty sure that there is. And if there were pieces that, whatever pieces that were missing, I would then remove so that I'm only keeping the four there. This graphic has lots of additional pieces that you can definitely tell was meant to color, maybe with crayons or markers. And I doubt it needs this much of a coloring book look to it. Jenny, what would you do for this one?
Well, I love the idea of going into the TGIL. And if I'm going to create it, then I also am going to simplify it a lot. I'll leave out the pictures. I'll just include the arrows and the labels. But another thing that I would love to do with this is have my student create it on something like the Draftsman or the Tactile Doodle or the Quick Draw paper.
And now we are at the stage where we want to make sure that we have answered some of your questions. If you have any questions in there, someone did ask someone else, did they have specific tactile pens they liked to use? So that's something that I think somebody would really like to know. Is there any other questions that we have out there that we might not have answered? As you're thinking of them, I'm going to move on and share our references. Lots of references there, and they're in your slide deck, in your presentation for you to be able to see. But we also want to share with you, we have 2 more upcoming webinars. We have Designing Effective Tactile Displays Using the Tactile Graphics Kit. That's that aluminum sheeting kit. And we are actually going to talk about the ways to use this graphics kit. And if you have one, there is going to be time for you to actually practice using your kit with us. So we're actually going to get on camera and give you some demonstration so that you can work along with us. And then decoding digital graphic design. We are getting into the designing of tactile graphics with the Monarch. So please join us for those. We really appreciate the time you spent with us today. And if you have any further questions, you are welcome to drop them in the chat for our last few minutes. Thank you. Thank you, Jenny.
Thank you, Leanne. Thank you, everyone.
Amy, I'll turn it over to you.